Hello everyone, in this video I'd like to discuss one very interesting topic. That is how can we use the PLC to implement the correlation coefficient calculation. When we have some data and try to get the statistic analysis, maybe the correlation coefficient calculation will be very essential and very basic function we need. So what is a correlation coefficient? This coefficient result usually can be used to do the statistical measurement to show the strength of a linear relationship between two variables. Some cases in the industry automation world, we can use the calculation coefficient, this value, to represent some relationship between different sensor or variables we acquired. For example, if we have a pressure and temperature and a float, if you try to find the key relationship between those values, and especially for the diagnostic purpose, or find out some explicit relationship between different values, then we can use the correlation calculation. And if we quickly review those static knowledge, we can search correlation efficient. And then we'll find this page. I will prefer go to this page and the correlation efficient calculation, what it is. So we can click this page and then we get this page. So we will see the correlation efficient to measure the strength of the linear relationship between two variables. The coefficient value will give you the value from the -1 to 1. If this value equal to 0, that means these two variables doesn't have any relationship. If that positive or negative, that means somehow they have some potential relationship each other. Especially if you are compare one reference variables, compare with some others variables, then you can find out the biggest the value from this coefficient. That means those variables, they have a strong relationship between each other. So we will see here, the correlation coefficient are used to assess the strength of the association between data variables. Okay, so you can review this page. The key things to calculate the correlation coefficient, we will use this equation. The denominator area, this is actually covariance of variables x and y. And the denominator area that come from two areas, come from the standard deviation of the x and the standard deviation of the y. So when we learn the static knowledge, we will see a bunch of like this, standard deviation and the covariance. When you learn these things, this looks very confused. And then we will see this maybe become a little bit clear. However, you will feel scared. Those bunch of summary at here. So how can we use the PLC or even C language, C++ or any other language, especially in the industry area where we use the PLC, we could use the structured text programming language to program to implement this equation. How we can do this? So in this video, I like to explain how can we implement this equation. More importantly, this correlation, this equation, that actually can be used as a good reference. So when we try to do some linear regression calculation, you will find based on this equation, actually this area, once we change y to x itself, then this equation will change to calculate the gradient when we use the linear regression to calculate the gradient. So that's why this method will be very useful when we calculate standard deviation, covariant, or linear regression. So this can be used for multiple purposes. Okay, in this video, I will use this equation. The implementation platform, I will use Beckhoff TwinCAT 3 program platform. And the programming language, I will use the structured text. So using the TwinCAT 3, this could be a general, especially if you are the research student. Using the TwinCAT 3, you do not need to purchase any license. You can practice by your own. Definitely using the similar concept, you can use Siemens TI Portal or use the Allen Bradley Studio 5000 using the structured text to program the similar way, or using the CodeSys system to program. The concept, they are the same. So in this video, I will use Beckhoff TwinCAT 3 to program this equation. And if you still feel a little bit confused while you are watching these equations and the explanation, so we can also use this way. Let's go to the Excel. I prepare these three arrays data here. Okay, the A data is this, B data is this length, and C data is this length. Their unit, they are not the same. For example, this B may be the flow, and A may be the temperature, and the C may be the pressure. Definitely, their unit, they are not the same. However, we probably can find out the relationship between them to find out who and whom they have a stronger relationship. So if I use the Excel and go to the insert and click this chart, then we will see the A, B, C, these three charts. So if we have a glance from our eyeball, we could tell definitely this E and C, they have a higher, stronger relationship. So how can we use this coefficient to represent this relationship? Then we can go to the data and select this data analysis. If you cannot find the data analysis, you can go to the file, click the options, and then go to the add in. And from here, you can click this go and check active this analysis tool pack. Okay. So we can go to the data analysis, and then you can find this correlation and click OK. So then we can select this input range. So I can select these three arrays here and select this new datasheet. Okay, click OK. Then the output will export to the new sheets at here. So from this result, if I copy it back, so we will see from the column 1 to the column 2, the coefficient, this value is 0.6. But the column A and the C, that coefficient value is 0.8. The higher value approach to 1, that means they have a stronger relationship. So from our eyeball, we will see that A and C, they have a stronger relationship. So the coefficient that shows 0.87. So this coefficient can tell us the strength of the association between those variables. So A and C, they have a stronger relationship. Okay, so we can use the PLC to use those data as a data source, and let's see if the PLC can calculate the same result, this coefficient value. Okay, let's go to the Beckhoff TwinCAT 3 system. Alright, this is my engineering system for Beckhoff TwinCAT 3 system. So I can right click the Run as Administrator, and let's open the TwinCAT 3 software. Okay, and then let's open the file, New Project. And let's pick one location. Okay, I set up one directory and this folder, correlation, this folder. And we can name this TwinCAT project to correlation. Okay, we set up this project, and then let's create one PLC project. Click New, Item. We will set up this PLC project in the same folder under this project directory. This is PLC. So we can name that PLC, empty PLC project. And then I will quickly set up some environment. This we discussed in my channel in multiple videos. So firstly, let me go to the real time and let's click this retarget. So I will assign one isolated core and click the set to target. Okay, and save. And then let's go to the license. Let's active one trial license. Click this 7 days trial license. And if this is the first time, you will see this area maybe turns red. Doesn't matter. So you can click this D, type in the same name at here. It will give you 7 days trial license. This is the beauty of using the TwinCAT 3 system. So that's also a key reason I'm going to use this TwinCAT 3 platform as my demonstration. Because even you are a student or new learner, you can use this free license software to practice your programming. And after 7 days, you can reactive another 7 days trial license. So this engineering platform, basically that's for free. And now let's go to our main menu, go to the PLC area. Then let's go here. Okay, our main program will be programmed from this main area. And the variable will be located as GVL global variable list, this here. And the correlation, this calculation definitely could be used for multiple purposes. That's why in this video, I will use the function block. We will create all the calculation within one function block. So once you build up this function block, you can use this function block for multiple purposes. And this function block can be used as one library. Okay, so here I will declare one variable list first, GVL. Okay, and also from here, the POU here, I can create a POU, and I can create the function block at here. The function I can name FB prefix, and we can call that correlation. Okay, correlation coefficient. Okay, and open. All right, so once we open this function block, we will see it has input, output, and a variable at here. So first, let me create some integer that represent the upper and the lower bound. So we can define how many data within one array. So here, as an input of this function block, I can declare a lower bound. The default value, we could start from 1. So the array, we can also start from 1. And the upper bound, we can declare, for example, default could be 5, for example. That means we could 5 elements in one array, okay? And from here, between the input and the output, let's manually declare one area that I named variable input and output, in out. Okay, so this is the area for the input, okay, and this is the area for the output. The input output, because we will use this area to receive the X and the Y, two arrays from the outside. And once we receive this array, go into this function block, we also need to operate this array. So that's why I will prefer use the in out. Okay, so at here we will create two array, and the easy way to receive the array, I will prefer using the structure. So let's create a structure. We can name that structure underscore correlation array. Okay, and from this structure we can declare the array data. This array data is based on, and this array could from the 1 to 20. And this array length could start from 1 to 20. The 20 can be changed in future. So if you do have a longer array, so you can declare this length to a bigger value. And this array, the data type we can declare as the long rail. So usually for those calculations, because they are slightly complex, so I will prefer using the long rail. That calculation could be more accurate. Okay, let's save. Okay, we declare this array. Okay, we declare this structure. This structure includes the array. And then we can go to the in out here. So firstly, let's create the array X. So firstly, let's create the input array X. That data type can based on this structure. So we can right-click, click this rename, and copy this name. Okay, and then we go back to here, and this array X, that structure can based on this. And its a data type is based on this structure here. So we can paste here. Okay, and then array Y. Same thing, the structure. Okay, data type, save. Okay, so this is two important array we will receive from outside, and then we will operate them. And then if we go back to this equation here, so we will see there are a couple important elements to calculate this entire result. Firstly, we need to know how many elements from this array. This named N. And then we have the array elements from X and Y. So this area means from each elements from x and y, they will times together, multiply together, and then we will summarize them. And this area means the x elements itself, we will summarize them together. And this area, similar idea, the y elements, they will summarize together. So let's firstly figure out these 4 elements here. So let's firstly deal with this n. So go back to the program. We will use the n. So the n could come from the upper minus lower and the plus 1, right? So we can go to the variable. Let's declare this internal variable. So this variable, let's declare this as the varn. Okay. So let's declare the numbers as a double integer. The double integer will have a similar length as a long rail. Okay, let's declare this variable as a double integer. Okay, so then this variable n is equal to the upper bound minus lower bound and plus 1. Right? So this variable means how many elements from this array. Okay, variable n. And then we will program one for loop. Okay, so before we start the for loop, let me create an index integer. Okay, the variable index. Okay, the variable index. That data type could be the integer. So we will calculate the elements by elements. So this index will start from the 1 to 5. So this will be the for loop. Then from here, we can type in the for loop. And the integer, this index, will start from the lower band to upper band. Then do. Okay? So this is the for loop. So what we'll do for the for loop, then let's quickly review the equation first. So follow this sequence, we got the n already. Then let's calculate the summary of this x times y, elements by elements. So how can we do this? Let's go back here. So let's firstly declare one variable that can named variable sum x and y. Okay, and this is the long rail. This is the variable xy, sum xy. So sum xy, that can equal to the elements by elements cross x and y, right? So how can we read the elements from this array? So this is the array name. The array name, the elements that are indexed by this integer value. Okay, this is the x. So we'll time the y elements. We'll time the elements from y. And the index number come from this index here, right? This is the x and the y element by element. They multiply each other. And how can we do the sum? Sum, we will accumulate them together, right? So every loop, it will accumulate itself. Then this equation represents the sum of the elements by elements across x and y. Okay? So this area. Okay, so we can write the comments here. This is the sum of xn times yn. Okay? Good. And meantime, don't forget, we need to initially zero. Otherwise, this accumulation will keep going, right? So before we start this for loop, we need to initial this sum xy to 0. Similar idea for other sum calculation. Then go back to the equation. We will calculate the x element, the sum by itself, and the y elements, the sum by itself. Okay, let's go there. So we can declare the variable sum x long rail and sum y long rail. Okay, so sum x, similar idea. If I calculate the sum of xn, so this variable sum x will equal to accumulate itself and then use the elements of this array x. It will sum itself. Okay. Similar idea for the sum of yn. Okay. So if we are dealing with yn, so the sum y will equal to the sum y itself and plus the array of y using the index value here. And don't forget, these two sum result also need to initialize as a 0. Okay. And the all long rail, so the initial value will be initial as a 0, 0.0. Okay, sum y. Okay, so this area basically they are denominator and this numbers of the elements. Okay, and then let's go to the equation again. So we calculate this portion. So we calculate this portion, this portion, and this portion. And then let's figure out this. The x squared and sum together. And the y squared and sum together. Okay? This is easy because this area is this area square itself. Take care of those difference. This means each x elements need to be square itself, then sum together. But this means this sum result do the square. So this is totally different. So this area is very easy because we just need to multiply 2 times, okay, of this result. That's enough. Then that means the only things we need to figure out is the x element square itself and sum together, and the y element square itself and the sum together. Okay, and they are similar idea, right? So how can we do this? If we follow the concept of this, it's actually also easy. So let's go back to the program. Okay, so we will declare 2 variables. So variable sum x squared long rail, and the variable sum y squared. Then let's start calculate within this for loop. So this area we will calculate the sum of xn square itself. So then the result of this variable sum x is equal to, it will accumulate itself and plus the x element square, right? So then we can use this way. The x element, right, times x element multiply the x element itself. Okay? And then do the similar way. Sum of yn square. Then this variable sum y square equal to this accumulation itself and plus the elements y element multiply itself. Okay? Okay, sorry. Don't forget this sum will also equal to 0 as the initialize y. Then as we can see here, actually the important elements to calculate this entire equation, we all got those sub elements already. So we have n at here. We have this area is this. We have the sum x itself. And we have sum y itself. And also we have the x element square and the sum together, this. And we have this y square elements itself and then do the sum at here. Okay? And this area is the same as this area, just multiply itself. Okay? And same thing for the y. This result multiply itself. That guy is square, right? Then calculate this coefficient will become very easy if we have this sub calculation already. Then let's figure out this equation. So firstly, let's figure out this denominator, okay? So let's declare this denominator. Okay, and then let's declare the numerator and the denominator, okay? The numerator and also declare a denominator. Okay, and also we can declare the coefficient result. So let's firstly calculate this denominator. So if we recall this equation, denominator equal to firstly the numbers of the elements, right? So the numbers of the elements is VRN. Okay, but this value, this is the dent. So we will convert the dent to long real. Okay, and then multiply the sum of the x and y cross multiply. So this variable sum xy, okay, minus the sum of the xn multiply the sum of the yn. So the variable sum x multiply sum of y, right? Sum of y. Okay, this is a denominator. Then let's go to the denominator. Okay, denominator. So firstly, we have a square root, SQRT. So SQRT is a square root. Okay, and this square root could have a big bracket because we have a multiple calculation inside here. So this square. So the first area element, this n multiply the sum x square, the element square itself. Okay, the element square and the sum. Okay, this one, and then minus this x element sum multiply itself. Okay, this is square. Okay, and this is the first portion. And then we can plus the second area, this is the y. The y will be similar. So firstly, we'll still use this numbers of the element times the y square element square. Okay, y element square, and the minus the sum y multiply itself. All right, so this is the two area, and then eventually we will do the square root. Okay, some cases you maybe think this square root has a little bit confused, so I can delete that. Let's firstly calculate this two area plus together this result. Okay, so this maybe become clear. So this is first area and the second area. Okay, this become very clear. And let's do this comma here. So this is denominator. And then we will do the square root of this denominator. Okay, follow the equation. Okay, then we will calculate the coefficient. And don't forget, we will divide this denominator. So that based on if this denominator must be greater than 0, right? Then we'll do the denominator divide this square root of this denominator. So the result is the variable coefficient. Okay. The coefficient equal to the denominator over the square root of this denominator. And this denominator must be greater than 0. Okay. And also you can program the else. So if this denominator not greater than 0, then you can output the error. Here we just show this key concept. Okay. All right. So this is the coefficient calculation. And then we could have the output here. Then the final output, this is a correlation coefficient. Okay. Okay. And this correlation coefficient, that's the long rail. Okay. And here, that equal to this coefficient result. Okay. So this is the key idea. And also because it's a summary here, don't forget, do the summary. Okay. So we basically finished this function block programming. And how can we use this function block? Then let's go to the GVL, the global variable list. Let me declare the array. So the first array, that's a long rail array. That's an array X, right? Its data type is the same as here. So go back to here. Its data type is the same of this data type. It's an array. That array based on 1 to 20 and it's a long rail. Okay. So go back to the GVL and let's declare the second one. Second one, long rail Y. Same data type. And then let's also declare the function block. So we will need an instant function block. So we can call that FB, correlation coefficient calculation. Okay, calculation. And its data type based on this FB. Okay, this is the instant. Okay, this is the instant right here. And then we need to declare a result. Okay, that result, that's the correlation coefficient result. Okay, and that's the long rail correlation. And that's the long rail. Okay, then let's go back to the main. From the main, we can call that instant function block. So we can type in this input assistant. From this test, let's search correlation. So we find this function block. And also we can find this GVL. This is the instant we declared. It's based on this function block. So we can click OK. Then we will see it automatically generates this input and output, these interfaces. So this upper bound and lower bound, this is integer. How many elements we have in this array? Then if we go back to the Excel, if we use this data array as an example, okay, so we can count how many elements we have. Okay, totally we have 13 elements from this data array. So the upper could be the 13 and the lower bound is start from 1. Okay, so from 1 to 13. So this array X of the input of this function block, we will use GVL dot this long rail array X we declare. Okay, we declare here, and same thing for this long rail Y. Okay, from here we will type in. From here we will type in GVL dot array X, array Y. From here we will type in this GVL array Y. They all based on this st underscore correlation array, this structure. And finally the result. The result we can transfer to GVL, the long rail variable we declared right here. All right, we finished this program. And now we can click the save and we can download, active this hardware configuration and implement this program. So we can click the download hardware configuration, active configuration. Let's build the project and let's see if the program has some error. I believe it has error because I intend to have some wrong programming style. I want to specially show for you. So the system shows it has errors here. And definitely it has error because I intend to leave this error style like this. Okay, here, this is the syntax to represent the elements from the array. So from the different programming style to represent the elements from the array, they have different style. For example, for the C, C++, for this programming language, this is a structured text. They have a slightly different way to represent the elements. But for here, in the Beckhoff here, the TwinCAT 3 system, to represent one single element from this array, we need to do this. So if we manually type in this array elements, if we click the dot, then it comes with this array data. And if we press the dot again, it doesn't show anything. So actually, to represent one single element from this array, we need to use this. The reason why, that's because this structure, if we go to this structure here, is here. Within this structure, it named as this array data. Then when we use this big bracket here, that represents the single element. That's why here, this looks simple, but in here, the syntax, I'm wrong. So I need to specially use this way. Type in, add on this array data. The similar way, add on here for the Y element. Okay, for the X element, Y element. Okay. All right, so I corrected that. Okay, this is the correct syntax to represent each element. Okay, but for different programming language, they will use the slightly different syntax as here. You just need to be carefully about this area only. Other place, I believe, they are very common. Okay, so now we can click Save and Build and see if the system has error again. Okay, this time it doesn't have error anymore. Then we can click this downstairs Active Hardware Configuration, and then we can log in the program. So my computer can run as a controller to run this program. So this is the beauty of the TwinCAT 3 system. You do not need to any real purchased hardware. You just use your computer run as a controller without any cost, because now we are using the trial license. It has 7 days trial license. If this 7 days trial license expire, you can just click and type in again. Then it will give you another 7 days trial license. This is very beautiful. So you can keep going using this platform for your practice. Okay? Once you see this square is running here, that means this system is running. Then we can click this button, log in. This will be very similar as a code-sys system, right? So log in the program. So now the system is running. We can go to the GVL, or we can go to the PLC, and you can use this watch to monitor the variable list. In this case, I will use this global variable list. Let me firstly input the X. So let me type in the A array here as the X input, and the C array as the Y, this array. So let's see the coefficient result. If the result is the same as this result, coefficient result, this is 0.87. If the calculation, they are the same. Okay, so the first element, that's 60. And next one, 77.5. Okay, we type in all the data here, and then we can click this write value. Then all those value will write into this X array. This X array. Okay, this is the A array from the Excel. Then the Y array from the Excel, we can type in all the value from the C array from the Excel. Okay, so here, 1, 2. Alright, we type in all the data from the C array to this array Y for the calculation. Okay, then we can click this write value. Boom, we write in. And then let's go back to the main. And once we click this login, we will see the result. It's showing the 89. The calculation result that equal to 89.0. Let's see if that equal to the Excel calculate got 0.87. So definitely this result not correct. So let's troubleshoot. So to troubleshoot this, we can click this GVL, this instant DB, and right click this go to instant. Okay, and let's troubleshoot. Okay, I see the reason. That's because here I have one typo issue here. Let's log out. These two area result shouldn't be the plus. So if we go to see, if we see this equation, this two area that should be multiply. So this is my typo issue. Sorry about this typo. But also this is a great chance to show how can we troubleshoot the calculation. Okay, so this area, let's firstly make a bracket here. And this two area, they should calculate, use the multiply. Okay, this is the correct. Okay, multiply. Okay, so let's click, and this time let's click the login. Then let's go to the main first. Let's see the result. Okay, this time the result got 0.8741. And this will be the same as the Excel, 0.87. Because this coefficient value should be less than 1. That from the -1 to +1. So 0.87 that approach to 1. That means the current X and Y, the array, they have a strong relationship. So if we go back to the Excel, if we review again, so A is our current X and the C array is our current Y. So they have a stronger, so if we look at this, chart, we will see A and C, their trend are pretty match. That's why the coefficient value approach to 1. This is the same result as the Excel calculated, 0.87. And if we go to the Matlab, if we are going to use the Matlab to verify this result. So this is the Matlab result. You can type in the A, the input, type in the A array, and then you can type in the B array. Then you can use this command, correlation coefficient, CORR-COEY, and calculate A and B, these two array. Correlation coefficient calculation. Then you will get this R result. This R result, this 0.8741. This represent this two array relationship coefficient. Okay, and this result is the same as here, 0.87. That means our current calculation, the equation calculation from this function block, they are correct. The denominator, these two area that should be multiplied. Alright, this is using the PLC to implement the correlation coefficient calculation. And as we can see again, so using the Excel, we can quickly verify this result. And from this chart, we can see. So if we imagine the A is a temperature sensor, and the C, the value come from the pressure sensor. So from this collected data, we will see the temperature and the pressure, they have a very close relationship. So if the temperature has some issue, then we can use the pressure to have some correlated diagnose. For example, in the normal run, the temperature and the pressure, their coefficient should be within a certain range. For example, should be around 0.8 to 0.9. But if the temperature is doing something wrong, for example, going high in a short moment, then definitely their coefficient, this result will decrease dramatically. Then we can use this coefficient value to do some diagnostic. This basically makes your system very smart, can predict something. or could learn something, learn the relationship between different variables. Alright, this is the demonstration to use the PLC and the structured test language to program this correlation coefficient equation calculation. And the equation I'm using is here. So one more word, most of cases you will see the equation looks like this. But some cases you will see another style to calculate this correlation coefficient. For some cases, you may see the correlation calculation equation like this. This is the average of the x elements in the array, and this is the y average. So actually the result, using the different equation, they can get the same result. It's just the different style of the equation. Okay? But more common way, I will prefer using this equation. Okay? But don't worry, if you even follow this style, if you calculate the average x or average y at first and do the similar calculation, you will get the same result. I verified this already. Alright, this is the topic for today, using the PLC to calculate this correlation coefficient. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.